now we come to a very important point. So the picture you're seeing there is from an Iveco truck. Probably there will be more trucks like this coming. So this truck has 90 grams per second H70 receptacle and a 120 grams per second H35 receptacle. Now, what is the problem? And this is especially important for operators, but of course also for the manufacturers. Consecutive fueling, especially using the -5 protocol, is not allowed. If you would fuel first, for example, using MCF HFG, using the H35 high flow, and then you hang up your nozzle, and then immediately afterwards you top off with the H70, then, or in the future with imagine this is a high flow 300 grams per second version, then most probably it will result in overheating of the tanks. So there is a chance, there's really an important chance that this could happen. So this should be avoided. So what try to think about that. We can think about it simultaneously. One example as a countermeasure could be, for example, as an operator that you say, okay, this truck has first fueled H35 and then he's going to refuel immediately afterwards with H70. We will wait or not allow it, or you could say, okay, we will limit it to a non-communication pressure target or of 55 megapascal, for example. So there are several options about this. But this is something which we should solve together. It's a typical European situation because in United States and Japan, they hardly have any H35 stations. So they will not have this issue. It's really a European problem. And that's the only slide I have about this item. So I'm open for the discussion.
Baptiste, please go ahead.
Yes, just one additional point. Doing further investigation, it looks like there are also many bus stations that don't necessarily have an H35 high flow nozzle, but also H35, simply H35. And depending on the protocol and how fast you fuel the bus protocol, depending on the pre-cooling, you could actually also have the case on connecting first H35 on the H70, which always works normally, and after that you continue with H70 high flow or H70. Yes, so it looks like it could be even broader than just H35 high flow.
Yeah, very good remark, Baptiste, because of course there might also be trucks coming out with only an H70 receptacle and not any other, and an H35 normal nozzle fits on an H70 receptacle. So you don't even need these two receptacles to have the same condition.
So Vincent, maybe I missed this kind of discussion in the last years, but what's the idea behind it? Because as far as I understood, you just mentioned it yourself, I'm able to refuel with H35 on a H70 nozzle, or am I wrong?
Yes, you can. You can, but I want to inform that the -5 protocol has not been made or developed under the assumption that you first fueled it at H35. Because if you first fuel it at H35, you might come outside the hot case boundary conditions. It could be that your tank is 60, 70 degrees, at the end of the H35 fueling, and then you start with an H70 fueling. It's not made for that purpose.
But it could happen, right? I mean,
yeah,
taking in account that we have different actors on the field. But Ignacio wants to dive into the discussion as well.
Yes, I understand that this protocol, I mean, the assumptions behind the protocol. Now, considering that we have a one direction communication that is not mandatory, I mean, we still have the non-com refueling, and that is also not very reliable. We have around 50% of non-com fuelings in the field. My question is there a way really to prevent it? Because I already see truck, bus, whatever driver arriving to the station and then doing this and doing that. And well, you can put a sign with red letters, neon letters, whatever you want. But if it is ignored, then it is ignored.
There is a way to avoid it, and the example is shown here. So we did many simulations where we waited for a few minutes because we assume switching from H35 to H70 will not be done in 1 minute or so. You have to wait 2-3 minutes. And if you then limit your pressure to 55 megapascal, then normally you should never able to overheat. So even in non-communication systems. That's an example, but maybe there are other. I'm waiting for the manufacturers and operators of the stations to give us more ideas of what we can do about this.
Okay.
I have an idea that was presented in SAE.
Yeah.
Isolation valve on the vehicle. But I know OEMs are not happy about that. So the vehicle can protect itself.
Ah, yeah. You mean really a kind of solenoid valve at the inlet pipe?
Yes.
Okay.
Yeah. Carl, Jojo and Paul agree, obviously, to this idea. And that so the station manufacturer side obviously has a clear view on that.
Mm-hmm.
I thank for the support.
I'm writing it down in the notes. Any other remarks?
Seems not to be the case.
No, okay. Then I will go. Yeah, so the appendixes, I will just show you what is in the appendix, but I will not explain the details. So there is a PRR taper method. Yeah, you all know the situation when you have a very high pressure difference at a vehicle, for example, you cannot achieve a good SOC, and then there are other conditions also that cause problems. Well, this PRR taper method should solve this problem. You will have to read my explanation in the presentation, but I have to tell you that this PRR taper method has only been confirmed only on light-duty vehicle stations at this moment, has not yet been confirmed on a heavy-duty station, so we only have simulations. If you're going to try this PRR taper method, we would be very interested to see how it works. So please send back feedback to check if this really works or not. And then the other appendix F is estimation of the volume, because with light duty vehicles we could have a second pulse here that could estimate the volume of the tank, also in non-com conditions. This is practically not possible anymore on heavy duty vehicles. You would need to to give a pulse of kilograms maybe. So this appendix shows an example of how the volume can be measured during fueling. During the fueling. So you start with a conservative fueling, you measure the volume at a certain point, and then you can choose the table for the right table that corresponds with the real volume. So also in non-com conditions.